Okay, so I think we didn't have a meeting last week, but the week before I was again talking about my encoders where I put this vehicle here. And if I'd back up far enough, I could show you the pictures. And here I want to show a picture anyway, so let me do this. Let's say share screen, screen 2. Al, do you see my drawing here? My plot?
Yes, I can see it.
Okay, well, let me back up. Let's say come on. No, it doesn't want to work. Come on, come on, come on, come on, come on. Okay, so here's the here's what I was doing. As I said in the last few meetings, I was talking about this where I bought this bracket on Amazon. So it's got this arm sticking out, this flat arm, and you bolt an encoder on it. You can buy those encoders on Amazon, and then you can buy these encoder wheels. That's a precise diameter wheel that just bolts on the end of the encoder, and then it's got this bracket where you bolt it onto something. So there's one. Do this. There we go. So anyway, there's this T bracket here that bolts onto something. I just cut a piece of aluminum angle here and bolted to the side of my my roll bar, which is a piece of wood sticking up on my vehicle. And it's got this shaft through. You can loosen this bolt, and you can slide the wheel back and forth this way. So I was trying to get the wheel centered on this ridge right there. That's the center of the tire. So I was trying to get it centered on that. And let's see, I guess I got one more picture here. And there's just a side view of the same thing. So if we take a look at that. So you can see it's just simply, come on. So simply here's the back tire, and this thing just rides on top of the back tire. And so it's got gravity holding it down. And you can see back here, there's a spring on it that they give you. So the spring hooks on here and hooks on up here. So by twisting this shaft in the back here and then tighten it back down, you can control the tension on it. So it's just, you got gravity and a spring pushing that down against the tire. And it seems to be working so far. I was out. So while I got this picture up here, so again, here's the flat arm. There's a bearing in it right there. The encoder and wheel are hooked on out here, and then here's the T bracket that came with it, and I added this piece of angle bracket and just bolted it on there, just to get it on. I was originally, I bought this for my lawn tractor and decided I don't have enough access on the lawn tractor, and I didn't want to screw around and spend a lot of time on it. It's not going to work, so I just put it on this thing to test it out, because this thing already has on the axle down here inside, there's back here, there's a gear and another quadrature encoder, so I can read the actual rotation of the axle, and then this tells me the rotation of the tire, which directly tells you the since the top of the tire turns at the same speed as the bottom of the tire. It's like he just had his wheel. If you just, the wheel is just riding on the ground down here, it's basically giving you the same indication there. So that'll be handy if I can get both sets of encoders running at the same time and compare everything to see how much difference all that kind of stuff makes. So that way we talked about the last few meetings, said, well, all I got to do is take these wires hanging down here and hook it up to see these wires hanging down here. It's just four wires on the end of that. I had to hook them up to something. So what I ended up doing was, let's see, just kill this. I say, let's kill this. Okay, come down to the bottom here. And I lost my train of thought. Let's see, hook up the wires. So basically what I did was I've got the this view. I took one of these boards, my background is going to screw it up, but anyway. So I took one of these boards. It's the STM 32F401 board you can buy on Amazon. And if you buy, I think 5 at a time, or maybe 3 at a time, you can get it for like $5 a piece for this board. And then you can buy this little programming adapter. And depending where you buy them and how many you buy, they run from like $3 up to like $15. Sometimes you get 2 boards and a programming adapter for some amount of money. And my other option would have been I could use the blue pill board, and I could rattle off the differences between them. But for some reason, one of the things was when I finally found my old projects for making this stuff work. So for this board, I found that the projects and that everything was written to run on that board. So I went ahead and went with that one. So I just simply took the encoder wires, and they had stranded wire. I just soldered some solid wire and put a heat shrink on. So I just had stiff wires I can plug into a proto board. So I just got a proto board with one of these boards stuck on it. And I wrote some code using the ST Micro. Is that what they call it? ST? Yeah, I'll call it that. The ST Micro IDE system, the big full professional developer package that you can download. And I use that to write code for it. And let's go back. So anyway, first I took it out and I put the vehicle out in the yard because I sat there all night writing code for it. And the next day I went out and I just simply pried one processor board off and put the other processor board on the program. Took it outside and drove it around. I got some really stupid looking results and I didn't know why. And say, for instance, when I was done, I just had a little thing that looked like it went in circles about 4 or 5 times, and it was only like 0.01 meters diameter. And I thought, well, none of that's right, so I couldn't figure out what was going on. And then I had a plot that was showing I plotted the X and the Y encoder values. And noticed one of them was incrementing. So here's the plot here. One of them was going up like this, and the other one on the other side was going down like this. And I thought, oh, that doesn't seem right. So that told me one of my encoders was backwards. So I could have went back in the house, changed the code, programmed the board, swapped everything out, or I could just swap the 2 wires on the encoder, and that reverses the direction. So I did that and drove it around, and then it looked like it was working much better. So this was out in my front yard, and I was sitting probably here on the just sitting here in front of my house. And then I told it, I just drove it down the sidewalk with my remote control to the driveway, drove down the driveway to the sidewalk, started going this way, and I wasn't paying attention. And I drove over and hit the grass. So I backed up and then came back around. So the whole thing looks like this when I was done. And it should come like this and go straight up like this and go across like that, and then come back down and go like that. So I just need to go change all the various scale values I have in this stuff. So number one, the turns, it looks like the turns have to be a little bit sharper, and you control that by telling it how far apart the 2 back wheels are. And then I can't remember, I think it's it's odd because this first line here, it's kind of a curved line, and I don't know if I was actually doing that. I wasn't paying real close attention. I just want to see if it was going to work. And so I wasn't driving exactly straight. I was too lazy to even stand up and follow around. So I was just sitting on the ground and watching it, like you do a radio control car. And so this one that's kind of weaving back and forth. Well, that was in the driveway and I couldn't see where it was at. So maybe it really did that. And the one on the sidewalk that seems fairly straight. But once I make the corner, that one seems fairly straight. So I think I just have to tweak the values. And I was saying before that if I pull this into Excel and I could recreate all of this. And so that's one of the first things I tried. Before I did this, I took one of these same type of boards that had the code that just had 4 encoders enabled, and it would just simply read the encoders and spit those values out. So I went out, I logged that, and let's see, what was my point on that? Oh, so I ended up with the 16-bit signed values right off the encoders. And I thought, okay, now I need to take those 16-bit sign values, figure out the delta. How many counts did it change in this time slice, this loop? And then I need to sum that into a big 32-bit sign variable. So that's just the way I keep track of all that stuff. And so as soon as I pulled the stuff into Excel, I immediately realized I don't remember anything about running Excel. So I couldn't figure out. I was able to take the first step where I say, take this value and subtract the previous value to give me my delta. I could do that. And then I was supposed to take that and sum it into a big number. And I couldn't figure out how to do that. At that point, I gave up and thought, well, I'll just go put the real code into the thing. So I went back and took the code and copied all the code from Sammy 2, this robot back here, and I copied the code from that and dropped in, and that's, you know, the full odometry stuff. And that's when I went out and drove it. This is the results I got out of the thing. So that's kind of where I'm at the moment. I need to figure out. I think the easiest way to get the scale value set is go back to Excel and figure out how to all the steps to recreate the whole thing. And then you can just change one number and bang, it just redraws the whole thing. And you keep doing that until it looks square and all the corners look right and everything. So that's kind of where I'm at right now. I need to do that. Or if I don't want to screw around with Excel, I can just say write a program maybe in Python that opens the file and takes the two sets of encoder values and then runs all the equations, and then I could just do a plot in Python, and so it would look like this, but it would be, I would avoid the Excel step completely. So what you do is you get it so you can recreate the whole thing from scratch. You go and you change the scale value and run it again and see, does it get more square? Does it, you know, do the corners open up or close in by changing a number? And then as far as how straight the lines are here, which again, that's really encouraging right there. That as straight as that line looked right there as I was driving down the sidewalk, that means that, you know, the encoders on both sides seem to be picking up the values essentially at the same time. I don't know, because I don't think the diameter of the tire is going to make a difference when I run this one. I was saying that before, that, you know, the wheel riding on top of the tire is basically like the wheel riding right on the ground. So I don't think the diameter of the tire makes a difference. However, the old one where I'm reading it from the axle, if you're putting an encoder on the axle, then the diameter tire directly affects how your counts are coming in. So that one, you know, you have to, in that case, if you're going to go out and do experiments, you should get your air compressor, and mine's got a regulator on. I can set it to like say 30 psi, and go to one tire and fill it till it stops hissing, and then go to their tire and fill it till it stops hissing. And that's probably the closest I'm going to get to a controlled situation where both tires are going to be the same diameter. So it'll be interesting to find out if I run this method with the new encoder wheels, you know, if that does indeed ignore the tire diameter. So that way I can directly compare the two back and forth. So I got to figure that out. And that was another issue I came up with. I thought if I could just, because I think if I just put a computer on my existing microcontroller board and put a terminal on it, I think it's constantly spitting out the odometry messages. And then this one, when I turn it on, it's just simply spitting out the odometry messages. And these are just text messages. They're not ROS nodes, or they're not ROS topics at this point. They're just messages coming out of the boards. So that if I plug both of those boards into a computer and then have some kind of software that reads both serial ports at the same time, and whatever comes in, just write it to a file. So that way it would put the old odometry messages and the new odometry message in a file with them, you know, the kind of sort of alternate back and forth. And that way I could compare them directly as I drive around to see what all these things are doing. So that's kind of where I want to go with this. And this is how far I got last night. I drove it around and got these values and plotted it out. So that's what we're seeing right there. Let's see if I zoom in on that. Is that so? Right there again, I came around there and I wasn't paying attention. I thought, oh damn, I hit the grass, so I backed up and went back to driving. And that, but you know, it's not doing anything really stupid. I don't seem to be dropping counts. It's not, you know, jumping from one place to another. So it's encouraging that it looks as good as it does. And that was without any tweaking at this point. I took some numbers out of the SAMI 2 values and dropped those in there. And I noticed it said something about the width between the wheels said 0.5 meters, but I remember, and I saw a comment somewhere where it said I'd actually set it in 0.46 meters somewhere. So it could be, you know, just changing that to what if I can find the latest values that are in SAMI 2, since it's actually the same vehicle. And if I can just find the numbers written down, or go through this whole step of recreating everything and be able to, you know, being able to recreate it on the fly. So that's where I'm at with that. And other than that, I don't think I've really been doing anything other than, you know, thinking about, you know, these stupid little boards again, thinking about, you know, which ones do I want to use, and the one I'm using right now seems to be working out just fine. And it's, I say, you get them for about $5 a piece on Amazon if you buy. I think you have to buy 3 to 5 at a time to get that. And then the little programming module I already have. Let's see, it stopped sharing. a little programming module. I have a couple of these laying around that when I bought boards, I think when I bought the blue pill, I got like three blue pill boards and one of these programmers. And then when I bought the when I bought this board, I think it was like two boards and a programmer. So I've got enough programmers laying around that all works out well. So I'm fairly well set up on that. I just need to sit down and do it now, I guess, to figure out how to do that. Oh, back to the concept. If I could get a program that reads both serial ports and writes it to a file, I thought, well, let me just pull up something. I was going to go looked on just went to the internet and said, well, show me a Python multi-port serial logger, and various things popped up. I found one that uh, a guy has written code that handles the serial part. So it watches serial ports and it sees stuff coming in, it attaches the port, and apparently then returns. You know, if it sees a line of data come in, I think it gives you a call back. So if I have both of those, set it up so it runs two ports, and then just open a file and just write that out. I could probably create it that way. So I was just trying to figure out an easy way. Ideally I wanted a really easy way so I didn't have to think about it, but I can't find anybody that says, oh, here's a program, you run it and it will take two serial ports and log all that on the same file. So I'm still looking for that and still trying to decide what to do about that. So I guess that's where I'm at the moment.
So your axle encoder is still attached and working, right?
Yes, it is.
And you haven't had a chance yet to compare the axle encoder data with your new, I'll just call it the wheel encoder data.
No, I haven't, simply because, as I was just saying, I need something that reads both ports at the same time so I can log that data. Or I can take my new one and make it so it's published under ROS, and then I can just say record the ROS bag. So either way, I got to do enough steps in here. It's not going to instantaneously happen. I got to put a little effort into either way to get that.
No, I
So
understood the real time deal about reading both ports. I was just wondering if you could do that in I don't know. I haven't thought through it, but if you could do that in batch mode after the run.
well, I need some way to get the data to begin with. Right now, I'm reading one. I can read one or the other right now. So I can't get them both at the same time to compare them in anything.
Got it.
I guess
And
if I timestamp everything, I could go out and plug in both of them, and I could start up two copies of start up two loggers at the same time, and they're going to be putting data out in files. And then if I pull it into Plot Juggler, I think it'll let you slide it back and forth, to line up two plots. So I could probably do it that way too. But the more I keep doing things like that, I'm just getting around the fact that I just need to make it work. That I'm just wasting a lot of time on different things. I could just do it right to begin with and move on, I guess.
so the scale thing you're talking about, is that like trying to figure out how many, I'm going to say ticks per meter, what that value is, so all your math works out? Is that
That's one of them. And I just simply took my encoder wheels are 68 millimeters in diameter. And if you take that times pi, that tells you how far it moves in one revolution of the wheel, of the encoder wheel. And that comes out to 0.213 meters. And then I've got a 600 count encoder. And by the time you do full quadrature decode, and I got 2,400 counts. So I've got 0.213 meters and I've got 2,400 counts, and it comes out to some huge number like 14,000 counts per meter or something. Whatever it came out to, that's just an estimate. And then what you do when you're all done, you go out and you draw a line on the sidewalk. You go down, say 10 meters, and draw another line, and you drive that amount, and you take the numbers and divide it out, and that gives you a closer. That's how you can tweak it after the fact to get that one. And then as far as the rotation on the thing, since it's looking at the left wheel and the right wheel, and the difference between those tells you what angle you're going, you just simply put in, first you just take a tape measure and measure between the center of the two back tires. And that's where I came up the original 0.5 meters. That's how far apart the wheels are. And then with all the experimentation I was doing and all the recreating stuff in Excel, I was coming up with, I came up, I think 0.46 meters by the time I was done. And it's just a matter of having to do those and then look at the resulting plots to see if they look like they're supposed to be.
And on that IDE that you used, I mean, I always felt intimidated. I got to that, I don't know, I think it was called Cube. Um, and it started asking me about all these pins. Like you tell it what board you have, and then you get 50 pins or something. What do you do with all of that in that IDE?
Well, it's just a learning process. You got to figure all that out. So yes, you go to the thing and it says start a project. It says what board do you have or what processor do you have. So you tell the processor, and then depending, I think if you're created from scratch, then it will automatically pop it up and it shows you a chip on the screen. So here's your little square chip. It tells you all the pins on there. Then on the left hand side, it says here's the peripherals. You click and say, I want a CAN bus. When you click on that, bang over here, the two of the pins will light up on the board saying that's the pins you're going to use. And you say, I want a UART, then two more pins will show up and say, I want a timer, and then something will pop up and you select all the stuff. So yeah, that's a step you have to go through. You have to configure the thing to tell it where all that stuff goes. And yes, it can be quite intimidating. And when I go back to look at, I can't ever remember, but I was able to, since I had a project all built, I was easier to figure the stuff out this time around. So
Yeah, I never got past that phase. Like, I don't know what to do with all this.
yeah,
Anyway,
it's one of those things. If you use it all the time, if that's what you do for your job, you get good at it and it works. But if you use it, look at it every 6 months or once a year, it becomes even more intimidating to say, I know that worked, but now you have to go back and try to figure out
yeah, you have to
how to get the thing to work.
relearn it a half a dozen times.
Yeah.
Well, all in all, that looks like great progress and a new and additional way to capture wheel encoder data. Anything else on your list?
I don't think so. Something came up while we're talking there, but I forgot what it was now. So I guess it doesn't matter.
Well, if you remember, just raise your hand or something. Let's see, progress on my end, not a ton of progress, but a couple of new things. This is a board that finally arrived in the mail from, I think it was PCB Way, and closest to my finger is where the BNO 85 IMU would go, and then furthest from my finger is where I think this was a Teensy that I was going to use for that. And then there's the the lines connecting those boards, because currently I just have the B&O 85 mounted loosely on a perf board, I guess is what you call it. And then I have a little plastic deal that I 3D printed that'll have a top on it that'll cover that up, and that'll sit in there like so. It's not showing very well. Yeah, like so. Took a little bit longer for this board to show up in the mail this time than the last times, but then again, I didn't spend a bunch of money on postage. I think the board was a series of boards. I think the minimum order was 5, it looks like, and they were $6, and I chose the $6 shipping, so I think it took a few weeks to show up. The other thing, let's see, where's that share button? There we go. In my current, to produce an ODOM statement from GPS, which I also supplement with wheel data when the RTK drops, I have this function in there where the position of the GPS is offset from base length. So I go through the little bit of math to get an adjusted base link position. So I was testing code that in addition to adjusting that location based on the physical location or the implementation of the GPS, I wanted to offset on the IMU. So I've got the code that I want to put in that module to adjust the IMU, so that if the IMU is running straight up and down, no problem. But if you're on a hill that's a 17-degree angle, it'll adjust the base length position based on the pitch and roll of the IMU. So I've sort of looked at this and desk checked it 2 or 3 times, and so I'm ready to move that in and test that. So hopefully tomorrow, weather permitting, I can get out and test that and see if I get any better results about the line following the target path when it's on an incline. So I think that's pretty much all going on with me on the robotics side. Not too much this week.
So the other thing, it came back to me what I was talking about before, or what I want to talk about. Let me see if I can get this bigger and say share screen. Where's my share screen down here? And say screen 2. So even looking at this plot right here, if we consider that, depending on what you want to do with your odometry, it's probably not going to work. As I said before, if you and a couple of the last 2 meetings I put out in the chat thing, I says, here's some old places where I was talking about this stuff. And one of those videos, I was going through the whole thing saying, I took my robot and I created the data and then I put it into Excel and I said, okay, so it looked like this. And I said, okay, let's come up here and change this number up here. So I changed some things and run it again, and bam, the whole thing changes in shape. So if you just get to a point where it's kind of close, it turns out if you're just using odometry to get your distance and speed, from say this point to this point, it's going to be fairly accurate regardless what else is going on here. And the problem is with the turns. I'm not sure this turn looks kind of funny there. It looks like it's way too shallow compared to the rest of these for what I was doing. So you have to be a little careful if you don't get that adjusted ahead of time. But if I tweak it enough that this looks mostly rectangular, then if you're just using the odometry to measure over short distances anyway, it doesn't really matter too much. Because I found that no matter what you do, you go out and you drive long distances. This is even on flat ground. So if I'm driving in the grass, it's going to get even worse. So you can't really rely on it. You can't rely on it completely as you're driving around. If you had, say you're driving inside of like say on a basketball court where it's completely flat, completely smooth, and a nice hard surface, as you drive around there, you could tweak it to the point where you could reliably drive around and know where you're at. But as soon as you go into the grass or go between the grass and the sidewalk, or the sidewalk and the driveway, it's going to start doing stupid things to you. But anyway, the point is, if you're just using, say if you're just using it for distance and speed. So right now Al's using his to measure his speed to adjust his transmission. And then what they want you to do in ROS is you want to take this data and feed it into a Kalman filter along with your GPS and your IMU and a bunch of other things. And it just needs to know you can tell it to take the speed from this, and you might be able to tell it to take the distance from that. And it's just looking at very short distances. So it doesn't really care. It doesn't care overall when you start off at 0, down here. And when you get all done, you're not expecting this to be correct anyway. So that I just wanted to throw that out, that you don't have to spend your entire lifetime trying to get this exactly right, because then as soon as you take out the real world, it's not gonna be right anyway. So you just want to get to this point and adjust it till it looks fairly close, and then basically go from there, I guess.
Wonder, do you have GPS data by chance to overlay on that?
No, I don't. The only thing I have right now is just this data. I just got this board connected right to a laptop, and nothing else on the robot is logging anything. So that'll be one of the next steps. That's why I should just take this board and write a ROS node and start publishing that. And then I can fire up the whole thing. And I'll have all the data coming in at the same time, and I can sort that, write that to a bag file. So that's something that I could do. Just move on and do that. So
Well, it's definitely progress. I think it was, I was smiling as you were talking because yeah, I've had mine tractors sit on the hill and it goes like this and it makes a turn and that, I don't know whether it's the left or right, but let's just say the left wheel starts spinning like crazy. And I'm like, oh, that'll screw up the location if I were using only wheel encoder data.
yeah, and then
But
also
it's useful because you can then say, hey, I'm in a spin or my wheel is stuck and uh, I have one wheel moving and the other one not. What should I do about that?
yeah. And that brings up 2 points. That number one, you could have something just simply watching for that and saying that, is my odometry coming off my wheels, does that match my GPS and or my IMU? And so in real time, it just says, oh, gee, that's a problem. And you can either start ignoring it or switch to a different sensor or something. So that's something that would be, in the future, you might want to think about adding that, or apparently, or probably if you go to the robot localization with their Kalman filter, it would just simply ignore that anyway. It says, oh, gee, that's way off. That doesn't match my other sensors. And it would just simply stop watching that one, and it's going to start using your GPS and your IMU instead of the wheel odometer at that point. If that's what you're, if that's why you have that set up. And the other point that comes up, I was saying I could go back and manually replot this and change all the scale factors till it looks right. Or you could just write a calibration thing where the vehicle starts driving around, and as you're driving straight, say driving straight down the sidewalk here, it knows by watching the GPS and the IMU, it knows if you're going straight or not. And it could tweak the numbers up and down until the odometry says, yep, I'm showing it going straight now. And likewise, when you make these turns out here, you could take all the data from the other things and combine them all together and then possibly tweak these values. So you just go out and run it, and I could calibrate both my odometry topics at the same time by doing that. But that's probably going to be a lot of screwing around and take quite a while to figure that out. So I probably won't get to that right away. But it just seems like there's lots of things you could do. Just have a calibration phase. You take your vehicle outside and say, here, run a bunch of different stuff and calibrate everything you can think of. Calibrate your steering, calibrate your speeds and your odometry sensors and all this kind of stuff. So that would be a worthy thing to do, but that's not what I'm going to do at the moment.
Yeah, I think I ended up calibrating based on the longest straight flat piece of concrete I had in my driveway. So yeah, something that did the GPS, that would be cool. And probably be more accurate based on the fact that when you get out in the grass, it's going to have some slippage no matter what you do.
Yeah. And then I was going back watching the ROS agriculture videos, and one of the meetings, people were talking about wheel slippage, and it reminded me of the fact if you've got a tractor, a full size farm tractor with these giant tires and the big lugs on the tires, and you're trying to pull a plow or something like that, as you're driving forward, your wheels are constantly slipping as it rips up the dirt because you've got too much of a load on the thing. And that's something that really hadn't occurred to me that would ever happen. Usually I think, well, if you got a tractor that starts slipping, just one side will start slipping, like when you're driving your car on ice and one of your back tires starts spinning. That's what I expected to happen. So it hadn't occurred to me that both tires are going to be slipping at the same time while you try to pull something. So there's just more things that will come up, and you don't realize it until somebody points that out, or you look at your numbers and know, why is it doing that? It says my GPS says I'm going this speed, but my wheels say I'm going this speed. Well, it's because your tires are slipping is why that comes up. So that's just more things to learn and more things to play with,
Yeah, definitely.
or more things to watch for. I should say that.
Lament over figuring out why it's so hard to say, where am I?
Yep. So I guess that's all I got.
All I got.